Okay, so go ahead and give you a heads up. I believe I mentioned this yesterday. I'm not going to be here tomorrow. There's going to be a substitute. I know you folks are going to, do great for him or her. I don't know who it is. I've got just a little worksheet that I'm leaving for you to take a look at. You'll turn it in before you leave. But I mean, once you finish it, the rest of the time is yours. I'll see you on Monday. We'll go ahead and wrap all this stuff up because the last day I'm going to see you folks is Thursday of next week. Can you believe we've already got 1 week of school left? Yes. I will bring ping pong next week, yes. No, I won't be here tomorrow. But I will bring it next week. And there's also more good news because I'm considering this my Friday. Once we finish up with just a few problems I want to take a look at, we're going to do SEL today. So, yeah. Unless, of course, we want to make math the SEL. I mean, our time is running out. You know what? I think this is going to be our last lesson. See, it's sad, right? I mean, I got plenty of other stuff I could pull up. I could start you on trig, or I could teach you conics. I could teach you matrices. So it's going to make it special? Gotcha. All right. Well, here we go. So we've been recently talking about piecewise functions. So they're defined by different formulas for different intervals of the independent variable. So basically, you're taking parts or pieces of different graphs, and you're putting them together into a new sketch. And we saw yesterday that absolute value is a piecewise function. And I introduced you to the step functions, the floor function and the ceiling function. And everybody seemed to respond pretty well to those. And then the last thing we did yesterday was we actually started looking at some piecewise functions and how to evaluate them. Remember, these portions at the very end right here, these are what we refer to as subdomains. That is where that portion of a particular function or piece of it is allowed to exist. Okay. So now, let's take a look at this. Okay, so write the piecewise function that represents the graph. Okay, so for part A, you'll notice we've got 3 linear segments that we want to go ahead and take a look at. So for the 2 steep ones, we're going to go ahead and write them in slope-intercept form. But let's go ahead and take care of the easy one first. Yeah. Let's take a look at the middle one too. So it's a horizontal line. So the equation of a horizontal line is just y equals, but remember that's interchangeable with f of x. So we already have the y equals ready to go. So what would the equation of that middle graph be? It's y equals what? If I were to go ahead and extend it, and I saw the entire line, well, I would go ahead and say it's y equals 3. That's it. Y equals 3. So I'm going to go ahead and write that right here. Okay, let me go ahead and move this out of the way. But now here's the thing. Where does it exist? For all values of x between what? It can only exist between 2 and 5. Okay, so 2 is less than or equal to x, which is less than 5. And you'll notice the left side has a closed circle. That means it's included. That's why I have equality here, but the other end is an open circle. That's why I didn't put equality. So not only do we need to come up with the equation for that little part, but we also need to write the subdomain that accompanies it. Okay? Well, let's go ahead and try this first one now. So let's see. We can already tell what the y-intercept is. What is that? That's 5. So I already know that it's got to be plus 5. All I need now is the slope. Okay. Now, there's a couple of ways we could do this. Because I actually see it, we could just find the rise and run from the graph, or we could actually choose 2 points and use the formula. What would you prefer? The graph? Okay. So what we need are perfect points of intersection. Like, say, going from this point right here to this point right here. So let's see. I need to go down 1, and how far to the right? 2. So what would my slope be? Because it's dropping to the right, and we're going down, it would be a negative 1/2 x. Now, if I were to go ahead and draw the entire line, I mean, that is the function that I just wrote. Okay, so you need to write the function for the entire equation, but you're going to go ahead and restrict it based on its subdomain. Now, this line here, where does it exist? Now, it can't be -3 because what do you have at the end of that? You got this arrow. There we go. So it's going to be all values of x less than 2. See, because that line only exists 2 and less. And yes, I got an open circle, so I'm going to put no equality there. Okay. Any questions? Okay, so that's not too terrible. Okay. All right, let's go ahead and get that out of the way. So I got one more. Okay, so I need the equation of this line right here. So let's go ahead and find the slope. Let's say I want to start here, and I want to go right here. So what's my rise and run? So it's -1. Yeah, we're going to go down 1. We're going to go right 1. Okay, so we have a -1x. And if you just want to put -x, that's fine. Now, for this one, we could go ahead and actually use y equals mx plus b to find the y-intercept. Or we could just go ahead and kind of work backwards from the graph. But let's go ahead and use the algebra. This is what we're wanting. We want y equals mx plus b, right? Well, we don't know what the y-intercept is. We just figured out the slope. Is everybody okay with that? Gotcha. Now, all I need is an x and a y to go ahead and plug in. So choose a point from the line. Okay, so 6, 1. So you want to use 6, 1 right here. Okay, so there's my x and there's my y. So now we have everything else, and I can easily go ahead and figure out what the y-intercept is. So the y is 1. M is -1. We're going to plug in the x of 6. And there we go. So 1 is equal to a -6 plus b. So it looks like my y-intercept's got to be what? 7. So let's put it all together. -1x plus 7. Everybody okay with how I did that? Now here's the last thing. What's the subdomain? Where is it allowed to exist? All x what? There we go. All x greater than or equal to 5. There you go. That's a piecewise function. Okay. All right, so let's try this next one. Now, I'll go ahead and tell you for this, that parabola, this is 1. We'll make this one 2. And we'll make this one 3, just so we can kind of keep track of what one's which. I'll tell you, there's no dilations on this at all. It's just the quadratic parent shifted. But what direction? Remember, where does the quadratic parent start? It always starts at the origin, right? And it's always going to go through, something like this. Okay. But where is that vertex now? That vertex is -3, so the whole thing was shifted down 3. So what's my function? Okay, you're on the right track, but that would be a linear function because you said x plus -3. Okay. Remember, what is the parent function? What's just the parent itself? It's x what? How do we know we're dealing with a quadratic? The power is, so it'd be x squared minus 3. It's just a quadratic parent shifted down 3 units. Okay. What's its subdomain? All x what? Less than or equal to 2. That's exactly right. Okay. Now, the second segment right here, that's just another horizontal line. So that would be y equals what? -2 And it can only exist where? Okay. So 2 is less than x, which is less than 5. Both ends have an open circle, so no equality on either of those. Okay. All right, so think about what we did on the previous example. Go ahead and find me not only the function, but also the subdomain for that third part right there, that third piece. Okay. So give you a few seconds to try that. And actually, you don't even need the function to go ahead and get the subdomain. This would be all x what? Greater than or equal to, woo, 5. Okay. So now all we need to do is, if you saw the entire line, what would its equation be? Good catch. Mhm. All right, who can tell me what that function is? Anybody? X minus 3. There you go. Okay, how many people got that right? Okay, so let's talk about it. Now here, I don't immediately see the y-intercept. I mean, I don't have anything else. So we can at least go ahead and find the slope. Okay, so let's say I'm going to go from this point to another perfect point. So I'm going up 1 to the right 1. So my slope is what? 1. So that's easy. Okay, so y equals mx plus b. Okay, now we just found the slope by looking at the function. We don't know what the y-intercept is. All I need are an x and a y that I can plug in. So give me a point from that ray. Okay, so let's use 6, 3, this point right here. So 6, 3. So let's plug in. The y value is 3 equals, we found m to be 1 times x is 6 plus b. So 3 is equal to 6 plus b. So 3 minus 6, that's where we got the negative 3 from. Okay. That's what it be. Question. All right. Well, here we were given the graph and we were writing the piecewise function. This time we're given the piecewise function and we want to go ahead and sketch the graph. Okay. So graph the piecewise function. So this one contains a quadratic, an absolute value, and a cubic. Okay, so the best way to work one of these, I've had a lot of students in the past just go ahead and sketch each one of these graphs in their entirety and then go back and erase whatever they didn't need. You're more than welcome to that. I've always been a big fan. Use the boundaries that you're given. Like for this one, let's only go ahead and focus on this quadratic right here. Okay, does anybody happen to remember that form? I've actually got it written above. A times x minus h squared plus k. Starts with a V. It's the vertex form. That's exactly right. Okay. So here's my H. Here's my K. Now there was one thing though about that H. We had to take its what? We had to take its opposite. So I know for this one, the vertex is at -4, +3. So this goes all the way back. Oh my gosh, what is this? October-ish when we were going through this quadratics. So we have -4, 3. So we got a point right here. Okay. Now, let's go ahead and use this boundary. We know it has to exist, okay, from -1 over to the left. It can only exist in this region. So let's see where it's going to fall onto this line right here. So let's plug -1. -1/2 times -1 plus 4 squared plus 3. Okay, so a -1/2. Well, that would be a +3 squared plus 3. Okay, so 3 squared, 9 times a -1/2, so that's a -9/2 plus 3. Now, if you want to go decimal, that's perfectly fine. What is a negative 9/2? Negative 4.5. So maybe that'll make it a little easier. So what is a negative 4.5 plus 3? Negative 1.5. So see, now we've got another point on this graph. I know that if I go ahead and take, okay, plug in a -1, we got a negative 1.5. Okay. Now here's the thing. At this location, will I put an open or a closed circle? Why? Because we have equality for that -1. So -1, negative 1.5. There we go. Okay. Now, what's the minimum number of points you need for a quadratic? You need a minimum 3. Okay. Now, we could go ahead and plug in another point, work through it, but make it easy on yourself. Remember something about parabolas. Every parabola, no matter what direction it opens, what does it have going straight through the middle? Does anybody remember that? It's the blank of blank. Axis of symmetry. That means if I fold along the line, the two parts are going to come together perfectly. Well, if this is my vertex, and I know it opens down because of the negative, here's the axis of symmetry. Okay. Well, all I need to do is take this point at -1, negative 1.5, and just flip it over. How far is that point from the line of symmetry? It's 3 units. So I'm just going to go 3 units in the other direction. There you go. So there's the first part of your piecewise function. Okay. Let me go ahead and get rid of those. So see, you've only got a piece of that parabola. Now you're wanting to do the same thing when it comes to the absolute value and the cubic. Okay. Now, you can also do the same thing to find basically what could be considered the vertex, even though they don't have a point like that on these. This could still be your H and your K. This is your H and your K. You can still use the same idea to easily get a point on those other graphs. And definitely go ahead and use the boundaries that are given in the subdomain. Okay. So what I'm going to have you do is try this on your own, but we're not going to get back to this until Monday. So tomorrow, if you want to go ahead and get it taken care of, or sometime over the weekend, that's all you got to do is finish up these 2 graphs, and then we'll finish this up on Monday, and that is all we have.